Hi, this is Prasanna from Wave Academia. In this video, we are going to discuss how to calculate the energy and battery capacity for the given electric vehicle. The agenda of this video is only to calculate the energy from the given vehicle. So how much energy is consumed by the vehicle and what is the battery capacity required to satisfy that vehicle. The motion and dynamic equation of vehicle, how to calculate the torque and power for the given vehicle, those things are all we already discussed in my previous video. So I shared the link in the description where you can see how to calculate the equation, that is opposing forces acting on the vehicle, how to calculate the torque, power and force required to drive the vehicle with the given drive cycle source. In this video, we are going to discuss only how to calculate the energy and battery pack cost. So before that, I will give you a short description what are all the opposing forces acting on the vehicle. There are four opposing forces acting on the vehicle, that is rolling resistance, aerodynamic drag, uphill resistance. It is also called as grading resistance and acceleration resistance. So once we calculated all these four resistance, that is opposing forces, then you can easily calculate what is the total tractive force required and what is the power required, torque required to drive the vehicle. The formula to find out the rolling resistance is given here, m into g into fr into cos alpha. I'm not discussing much about how to calculate what is the impact of m, g, fr and cos alpha because we already discussed in one of a previous video. You can check the link. Aerodynamic drag, third one is grading resistance, it is also called as uphill resistance, and the fourth one is acceleration resistance. Once we calculated all these equations, all these opposing forces, then it's the time to calculate the total tractive effort, power required and required torques on wheels. So once you want to calculate the torque on wheel, we need a radius of wheel. None of the manufacturer won't give you the radius of wheel explicitly. They will give you only the tire mark sizing. We have to calculate the radius of wheel from the tire mark sizing. That is also mentioned in the previous video. Please refer that link. So in this example, these are all the specifications which are used in the simulation for the given vehicle. Mass of the vehicle is 1600. Acceleration due to gravity is 9.81. Rolling resistance coefficient is 0.01. Grading angle 10 degree. That slope of road is 10 degree. In considering that, and the density of air is 1.18. Vehicle frontal area is 2.5 meter square. Aerodynamic drag is 0.32. Rotational inertia constant is 1.05. Radius of tire which I used is 0.4 meter. Now I am moving on to the important requirement of EV. This is my electric car requirement. So considering a city electric car designed to have a range of 350 km, which consumes, we don't know how much energy it is consuming from the battery pack to operate. We don't know that the first step we are going to calculate. Okay, so I'm going to design an electric car which can satisfy a range of 350 km. So I want a battery pack of which can satisfy 350 km. I'm considering the depth of discharge as 90% and the battery is having a nominal operating voltage range of 48 volts. So various batteries are available. Operating ranges are 48 volts, 60 volts, 72 volts are available. So accordingly, you can design. In this case, whatever the nominal operating voltage of battery which I considered is 48 volts. The auxiliary power requirement is 5 watt hour per kilometer. This is very important whenever you're designing a battery for an electric vehicle. You have to consider how much power consumed by the load. So there are two ways. One way, you can use a separate battery for loads. For an example, you can take lead acid battery. Lithium ion battery is main battery. It's a main battery for vehicle running. You can use a one more auxiliary battery, that is a lead acid battery, for providing a power supply to your vehicle accessories, say headlight, cabin lights, parking lights, so various sensors. So those things require power requirement. You can use a separate battery. Otherwise, the second way is you can include that capacity in the main battery also. So in such cases, you must include the auxiliary power requirement in the battery pack design itself. Okay, and the cell parameters, the individual cell parameters, lithium ion parameters is given, lithium ion cell is given. The nominal voltage of single cell is 3.65 volts, cell capacity is 45 ampere hour, the weight of single cell is 0.33 kg, and the dimensions of cell is given, length, breadth, and thickness of the cell is given. So with this requirement, I'm going to design, the first step of design is I'm going to calculate how much energy is consuming by the car for the given drive cycle source. So based on the energy consumption, I'm going to design the battery pack. That will be the idea of this video. Now I'm straight away going to the MATLAB. The MATLAB program is which I already developed. Okay, I will explain step by step. If you want to know about how to develop these videos, you can refer my previous videos, which I already mentioned. I'll paste the link in the description where you can see the videos. So I'm straight away going to the MATLAB. It's a Simulink. So first take only this portion. Only take this portion. So this is the place where I'm going to calculate the power consumption, energy consumption, whatever the thing. Okay. So look at this. This is nothing but, the first one is nothing but it is a rolling resistance force. Second one is aerodynamic drag. Third one is grading resistance. And fourth one is acceleration resistance. So it's a subsystems. Depends on the equations. You can refer this PPT. Depends on this equation which I created the forces. The first one is rolling resistance force. Mass into G into rolling resistance coefficient into alpha. Similarly, aerodynamic drag according to the equation which I developed. The third one is grading resistance. And the fourth one is acceleration resistance. So once you add all the forces, this will give you total tractive effort. The total tractive effort multiplied with the velocity of vehicle. This is nothing but it is a velocity of vehicle. So it's a real-time velocity which will normally given by a drive cycle source. It is available in the MATLAB. I'll tell you where to pick this one. Go to library browser. Go to vehicle dynamics block set. There go to vehicle scenarios. There go to drive cycle and manuals, where you can find a drive cycle source. This drive cycle source is available only in advanced version of MATLAB, that is maybe after 2020 or 2028. Okay, so older versions you cannot find this drive cycle source. Whatever it's a drive cycle source, it's a US drive cycle source FTP 75. Federal Test Procedure 75. It's having a total length of 2474 seconds. If you want to see the drive cycle source, just double click it and click on plot drive cycle source. So this will give you a drive cycle source. You can see this. In x-axis you are having a time and y-axis you are having a velocity in meter per second. If you want a meter per second, you can choose it accordingly. Otherwise, kilometer per hour, miles per hour, everything is available. You can select it. So it's a it will give you a velocity profile of vehicle under various road conditions. What is various road conditions? You can take a velocity profile in high traffic density, moderate traffic, low traffic density, in hill stations, in highway ride. So likewise, you can take a different drive cycle source. So I'm going to give this drive cycle source as an input. In aerodynamic drag, you can straight away feed this velocity. But for acceleration distance, as per the equation, it required acceleration. Whatever the input I'm having, only a velocity. This one is, it's a velocity. So by basics, if you take a derivative of velocity, that is dv divided by dt, which will give you acceleration. So that's why I'm using a derivative. Derivative of this velocity signal will give you acceleration. Okay, so before that, make sure what is the vehicle parameters, which I already mentioned. You can refer the PPT. So these are the specification used in simulation for vehicle. Mass of vehicle, rolling distance, everything with respect to the equation is given here. So go to MATLAB, create one M file. Okay, load all the variables with the values and execute the file. Make sure that the values are available in the workspace. Now you can go to MATLAB. Okay, hereafter you have to call all the variable names. Okay, don't make any mistakes. It's a highly case sensitive. Once it is done, you can easily calculate what is the total tractive effort, power required and torque required of vehicle. So I'm just running it. You can see this is the total tractive effort of the vehicle. This is the total tractive effort of the vehicle. So this is the output with respect to the input, and this is the power requirement in kilowatt. So it's having a positive power as well as negative power, because whenever the driver applies the acceleration, the power requirement will be reversed. Actually, it will be in regenerative mode. At the same time, if you look at the torque, this is the torque requirement. So from this study, you can easily pick what is the maximum power required and maximum torque required to drive the vehicle. So up to this portion, you can refer my previous video. So hereafter, I'm going to calculate energy consumption of this vehicle. Let me consider that this is my vehicle now. Okay, how much energy it is consuming, that I'm going to calculate now. So for that, I need some space. Okay. I think this portion, vehicle dynamics portion, is clearly visible. So how to calculate the energy? Energy consumption. Energy consumption is nothing but it is a how much energy is consuming with respect to kilometer. So that is watt hour per kilometer. That's what I'm going to calculate. Watt hour per kilometer. Here I'm having watt. If you look at this, it's a power. I'm having a watt. So whatever the power value, it's going in negative way, negative values. I don't want negative values while I'm calculating. So let me take absolute ABS. So this will give you only the positive of power, ABS. And then I'm going to integrate this power. If you integrate the power, this will give you energy, that is watt second. If you integrate this power, This will give you traction energy, that is watt second. This is the place you will get watt second. So after that, we have to convert that watt second into watt hour. Therefore, I am taking a gain value. The value of gain is 1 divided by 3600. This will give you, this will convert watt second into watt hour. So now the same energy tractive energy in watt hour is available. At this stage. So what I need is watt hour per kilometer. As of now, I calculated watt hour. How to calculate kilometer? See here, I am having a velocity. The velocity, unit of velocity is meter per second. First thing, I am going to convert it into meter. That is a distance. I am going to convert velocity into displacement. How to do it? Take an integrator. Connect this velocity with the integrator. This will give you distance in meter. That is a displacement in meter. I don't want in meter, I want in kilometer. Therefore, I am taking a gain. Let it be the gain value is 1 divided by 1000, which will convert meter into kilometer. Here it will be in meter and here it will be in kilometer. So once, see, look at this. Now the distance in kilometer is available. Here the energy in watt hour is available. I need watt hour per kilometer. So take a divide. This will give you energy consumed. That is watt hour per kilometer. So make sure that first you have to take the absolute value of power, because power is going in a negative value. I don't want negative value while calculation. I want it in power, positive value. So after that, I'm going to convert that power into energy. You have to integrate it. So this will give you traction energy in watt second. So if you want to convert watt second into watt hour, you have to do this 1 by 3600. You have to multiply it. So the second case, you have to convert the velocity into distance, which is in meter, again meter to kilometer. At last, if you divide it, this will give you energy consumption in watt hour per kilometer. Okay. Fine. So once you run it, you can come to know how much energy is consumed by the vehicle. Now double click the energy consumed. Consider. So always it will take the initial energy consumption will be very high. Okay, don't consider this initial energy consumption. Instead, you can take, see, somewhere it is settled. After over the period of time, the energy consumption will be settled. So I'm taking this value. Of course, this is an energy consumption, even though it is a variable one. But you can fix it as a constant value. As of now, I'm fixing a little bit. It's considered as 160 watt hour per kilometer. So what is the energy consumed by this vehicle? It is 160 watt hour per kilometer for this tricycle source. Okay, so you have to repeat the same kind of procedure for different tricycle source, then you can come to one conclusion. In this case, I am using a tricycle source of FTP, is a Federal Test Procedure 75. For that, for the given vehicle, it's a given as the energy consumption is 160 watt hour per kilometer. Approximately you can take. Don't consider that it is energy high. Initially, it will require high energy. Over the period of time, it will be settled. So this is the energy consumption consumed by the vehicle. So now I'm going back to the PPT. Now we look at this. So consider a city electric car designed to have a range of 350 km, which consumes 160 watt hour per kilometer on average from the battery pack to operate. Now it's a very important thing. Vehicle's energy consumption is 160. The auxiliary power requirement is 5. You have to add it. So totally it's required 165 watt hour per kilometer. This is one for 1 kilometer. I want to design a battery pack which covers 350 km as a range. Then it is simple. 165 multiplied with 350, which will give you the total energy required to drive the vehicle. Energy, total available energy, required energy. Okay, so total energy will give you, if you have to multiply total energy consumption for 350 km. So that's what will be the next step. So as of now, we'll look at this. The depth of discharge is 90%. The nominal operating voltage is 48 volts. And these are all the cell parameters. So how to calculate the available capacity of battery? The available capacity of battery, that is nothing but it is actually it is not energy. It's a energy of battery. Energy of battery. This is available capacity. So there is a lot of difference between energy and capacity. So voltage into ampere hour is energy. Capacity means only ampere hour. So how to calculate the available energy? Voltage into ampere hour. We know what is the watt hour, what is the energy. That's why we calculated. How to calculate? 165 multiplied with 350. That is nothing but watt hour. So we know that what is the voltage? Voltage of battery pack is 48. So from there you have to calculate ampere hour. See, this is the formula. So once it is calculated, then you can go for the total capacity of battery. Okay, it's actually total energy of battery. This one is total energy of battery. It's not a capacity, it's the energy of battery. Total energy of battery is voltage into ampere hour divided by depth of discharge. Depth of discharge is already given, it is a 90%. So once you follow these formulas, you can easily calculate the battery pack design. Then you can easily calculate the number of cells in series, number of cells in parallel, total number of cells, volume of battery pack, weight of the battery pack. Of course, driving range calculation, which is already given, you can check it back. Okay, whether whatever the battery pack we developed, it is giving the same range or not, you can check it out. Okay, so that's why I designed this portion. So we already calculated the energy, right? Now I'm going to the battery pack portion. So for battery pack also you can refer my old video. Okay, that video also I already share. The link also I already share. I'll share it. You can check it out. Take only this battery pack calculation. Okay, I'm explaining step by step. So what is the energy consumed by the vehicle is 160 watt-hour per kilometer. What is the energy consumed by the auxiliary road? It's a 5 watt-hour per kilometer. First, I need to calculate what is the total energy consumed by the EV. Add it. It will give you. And then I have to calculate the battery pack energy. Available battery pack. How to calculate available battery pack? I have to multiply with 350. What is 350? That is nothing but my range of vehicle. So then, if you multiply 165 with 350, this will give you battery pack required, the available battery pack required. So there is a lot of difference between available and total. Always total is high. Total energy is always higher than available energy. So as of now we calculated only available energy. Next step you have to calculate the total energy, because whatever the total energy you can utilize only as per the depth of discharge. You can utilize only 90% of battery. So let us consider the total energy is 100%. You can use only the 90% of 100. That is called available energy. Okay. So the next step is how to calculate the battery pack energy available. Actually, it is in kilowatt hour. The next one is battery capacity. How to calculate battery capacity? We know that watt hour is equal to voltage into ampere hour. Voltage into ampere hour. We know that watt hour. We know the voltage. Let's calculate ampere hour. That is a capacity of battery. That's what I did. So we know battery pack voltage is 48. It's given in the table of column. Watt hour, just now we calculated, it is 57,750 watt hour. That is nothing but it is a 57.75 kilowatt hour is the battery pack which I require. 57 kilowatt, approximately 57 kilowatt hour battery pack is required. So you can easily calculate the capacity of battery. So the capacity of battery is coming around 1203.25 ampere hour. Next, you have to calculate the total battery pack. How to calculate total battery pack? You have to divide it by depth of discharge. Okay, this will give you total battery pack. From that, again you have to calculate the battery capacity. See, don't confuse this. There are two battery capacities. So this is available battery capacity. Sorry, this one is available battery capacity. This one is total capacity. Because see, if you look at this total capacity, it's coming around 1366. in the 1366 ampere hour, you can use only 90 percentage. 90 percentage of 1366.80 is 1203.125. Remember, this is very important. Don't confuse. You can use only 90 percentage of total battery pack. That 90 percentage is called available battery pack. Okay. Once it is done, once you calculated the available capacity, now you are having pack voltage, cell voltage, which is given the table column, pack capacity. Just now we calculated it is coming around 1336. Okay, cell capacity, it's again given the table column. So once you have all these four datas, pack voltage, cell voltage, pack capacity, cell capacity, then you can easily calculate total number of cells in series, total number of cells in parallel, total number of cells, you have to multiply it, and then total weight of battery pack, volume of single cell, because length, breadth and thickness of single cell is given. You have to multiply it. This will give you volume of single cell, cubic millimeter. You have to convert it into liter. This is the conversion formula. So volume of battery pack in liter required it's 405 liter. So accordingly, you have to develop your vehicle structure. So you are going to place a battery in the vehicle, right? So what is the space required in the vehicle is 405 liters. Is a space, it's a boot space required in the vehicle to place your battery pack. So at last, from this design, you can recheck it out. See, if you look at this, the standard consumption is 165, that is 160 plus 5, which will give you the range of, if this battery pack will give you the range of 350 kilometer. So this is the way you can develop any energy calculation as well as the battery pack calculation for the given vehicle. Once you run this, you can check what is the energy pack, okay, what is the energy and what is the battery calculation. You can check out the values. This is the energy consumed, total energy consumed, energy available, energy that is total energy, number of cells in series, number of cells in parallel. Make sure that only take floor values. Okay, total number of cells, weight of battery pack, volume of single cell, volume of battery pack, volume of battery pack in liter, and the range of vehicle. I hope this video will give you the clear information about how to calculate the energy, and for the given energy, for the consumed energy, how to calculate the battery pack. Okay, thank you. Kindly subscribe the channel. If you have any queries regarding this video or any of my previous video, kindly drop a mail to this mail ID. Thank you.